I'm here in Sweden at Toyota, where I've been giving a lecture on the future of manufacturing, manufacturing 4.0, digital, artificial intelligence, different aspects of the future. But at the end of the day, it's all about teams of people working together in very precise ways, integrated fully with the very best of technology to do amazing things. About 80,000 of these things a year, and you can see them behind me. They're very precisely engineered, very heavy duty. You might be shocked at the sheer thickness and weight of the pieces of steel here. This is not building cars. This is building industrial machines that make other machines. So they're tough, they're built like tanks. And here behind me is a laser cutting components out of steel this thick. And the laser is cutting it at around 2 or 3 centimeters every second. So here we have sheet steel that has been laser cut to produce large numbers of components which are then knocked out so that they can be painted, assembled into other parts, and so on. And now they're being bent with colossal force, very thick steel, in a very, very precise way. I'm absolutely astonished at how quiet this place is, considering we're stamping huge amounts of steel at a very great thickness. We are laser cutting, we're bending, but the noise level is just a few decibels. So here's one of the robots, very thick welds, extraordinary strength and astonishing precision. So this is what the robots are welding, and if we come close, we can just see the sheer size and strength. This is like a military vehicle. It's just incredibly strong. It's made to withstand huge impact and massive stresses. So behind me we've got robots that are spraying powder onto metal. And this powder will then be baked in the oven at a temperature of several hundred degrees centigrade, which means that these powder particles coalesce together, form a liquid, and then when it sets, it produces this very, very hard industrial quality coating. So above me we've got trains. These are monorails, and they're traveling relatively slowly, carrying components on hooks from one process into another. In this case, they're covered in black powder and they're heading for the oven. So this is the buffer of the factory, because some of these pieces are only made 1.5 hours before they're needed on the assembly line. So this is lean manufacturing. You are running an operation literally hour by hour, making fitting out, sold, dispatched all over the world. And what's going on is a combination of the genius and the good ideas and the common sense of every single worker who's working on the assembly line, together with those that are controlling the robots in different parts of what we're going to see later, are all with one purpose in mind: to make sure that we have the minimum amount of waste, the minimum amount of wasted effort, and the minimum amount of time to do things really, really well. It's a low-level environment, it's easy to work in, and every person who's on the floor is encouraged to contribute their own ideas about ways to speed processes up and make things more efficient. Now, although it doesn't look like it, there are hundreds of robots working around here, but they're unobtrusive. They've literally got a low profile. They may be driving a platform around with particular components from one place to another. They may be supplying new boxes to one set of people who are assembling on the line. There may be pods, as we'll see in a moment, moving slowly down the assembly line. Come closer. So this little fellow is a part of a virtual conveyor belt. He's not on any railway lines or anything, but he knows where he is in the factory. He knows what he's carrying. He's carrying all kinds of components which are stacked up here, which are going to be used elsewhere on the rest of this assembly line behind me. We're now on the main assembly line, one of 5 lines down here, and these are going to produce 80,000 trucks this year, 120,000 in a couple of years' time. And each of these people is working on a platform, and the platform itself, if we have a look, it doesn't look like it, but it's moving very slowly, and the precise speed at which these different platforms move across the factory determines the number of vehicles that comes out. And each group of workers has precisely the same amount of time to do their own set of tasks, So we have many different stations, and then each point they move on. And each worker will change the station they work at several times a day to keep the work more interesting. And over a period of 2 or 3 years, they will work their way right through the whole factory. So behind us, we're assembling the vertical part of the mast of a forklift truck. That's that big black thing going up and down. And these are, you can see it's being turned. It's on the assembly line. The assembly line itself is a big conveyor belt, and it's moving. It's moving slowly, and the track time here, that is the time that it takes each station, is about 8 minutes. And for every worker, they've got a number of tasks they have to do, and the whole thing is about optimization, about being incredibly lean and efficient. It's all about learning. So where the spanner is located, where the components are, whether it's at the top left or the bottom right, these things all really matter. Because you want workers to be able to do these things almost in their sleep, just automatically, very easy, no strain on the back, safe environment. Now obviously, if you've got a tack time of 8 minutes, you've got teams at each sector working flat out to make sure they complete their tasks. But what if something runs out, or your drill's broken, or something's gone wrong? The answer is you've got 2 things you can press. One is this, yanking this yellow thing here tells the rest of the line that you need an assistant. The second is the red one. That's an emergency stop. That means I'm out, I can't continue. Stop, stop, stop. This whole line's got to stop, and everything immediately halts. Everyone downs tools. The supervisor will come, sort out what the problem is, and try and get the line back up and running in hopefully seconds, if not in minutes. So it's a highly precise environment, and the efficiency of the factory depends more than anything on how many stops you're going to get in a day and how long each one actually is. We have a minor incident here. So we got an orange light, which means the factory is still running, but we can't continue for much longer. We've got literally minutes to sort this out, or we're going to have to close the whole line for a minute, or for a little while. So the engineer's on site, we're trying to resolve the problem. We're on the phone, getting expertise and so on to repair the line, get it back up and running, and then we'll be flowing again. This is what it's all about. It's about response time, reliability, anticipating, and finding workarounds that enables a line to continue without halting the whole factory. Now, the important thing about products is learning from your own customers. Well, how about being your own customer? So Toyota uses 16,500 of its own forklift trucks in its own factories, and that data is absolutely vital in terms of reliability, ease of use and so on, to help shape the next generation of forklifts. Obviously, whenever there's a break for any human being, everyone has to stop because the whole line is halted. And that's the time when the maintenance crews come in, sort things out, and prepare the line for full operation very soon. I think the take-home message is this: that you can have all kinds of brilliant engineering and the best designs and so on, but when it actually comes to making things, it's a different matter. We're looking at predictive analytics. We're looking at combining lots of big data about failures, about problems. We're talking about optimizations. We're talking about fine-tuning things which may be very, very small to you or I, but will be mission critical in terms of the overall factory efficiency over the next year or two. We're talking about problem solving and the speed at which you can diagnose something that's about to happen and prevent it and make your intervention to keep that line up and running without any interruption. And above all, there's the human element. When we look around the factory, we need to make sure that every single person here is comfortable in what they're doing, they're safe, they're properly supervised, they're well trained, but they're also satisfied and enjoying the challenge. Because it's only when all of those things work together that you have a happy environment, and that means you get reliability that's sky high.